Alright, in this video we will continue from our last practical task, practical 2. So, today kita akan sambung practical task 2B. So, for practical task 2B, you are required to refine the mesh for the flat plate punya simulation into several cases lah. Base case is what we have done just now, previous, which contains the number of elements 60,000 lah. So we need to do meshing lah, remeshing of the model case A, B, C and D. So this is the number of element in X direction, this is the number element in Y direction, since this is the total number of elements. So kita boleh buat manual punya changes. So let's look at case A. It's very simple. What you can do, firstly, we need to clone the project first. Okay, so this one you can rename it. Is either use current or select or create new lah. So at the moment kita use current. So this one we may put case A lah, for example, case A. Okay, alright. So soon they will have case A appear kat sini lah. So this one is kita punya base case yang flow over flat plate, and this one is yang case A lah yang kita nak tukar meshing. Okay, so this one, since they're bold, that means whatever settings that we have here basically adalah for this case A. So right now we can change the meshing. So global mesh. So now in the setting we need an X60 and an Y40. So we change that to 60. And this one is 40. Okay, then click OK, and then we need to run it. So this one is new calculation, so kita just run lah. Okay, okay, see the progress. So right now it's mesh capturing, so finished, and simulation is running. Okay, so finish already. So this is the results. At the moment everything is green already, so we can compare the results that we have. Okay, so we want in this slides, in this power, in the practical, what you have to do is compare the velocity at x 0.6 in a single plot and compare the results of average surface friction coefficient, and comment on the effect of grid refinement on the simulations. So we need one results velocity profile and then average surface friction coefficients. So what you can do is we need to plot the XY plot. So let's open this file. Okay, velocity x. So we can export to Excel, atau we can show it. Let me show that. So this is the data that we have. We only want x 0.6 only lah, so we delete the other two. Okay, so okay, right, again. So let's show again. So this is the plot that we have. So what you can do, we can copy. You can copy by export to Excel. Okay, right. So this is the data that we have. This is the graph, and this is the plot data. So now what you can do, we need to take all the data that we have in the previous task 2A for 0.6 and then compile everything in one file. So I'll create new file, new workbook. Okay, and then I open the file that we have before, which is this one, practical 2. I'm not sure whether is it this one. Okay, this is the results for the first case. Remember the task 2A. So we can copy this one. Let me go back to the books X2. So this one we just rename it velocity profile. X 0.2 meter. Okay, copy first the data for the first case, base case, Control C, and then copy paste, Control V. Right, so this one is the, make sure that the first column should be velocity, so we need to transfer this column to the right. So just click and drag here lah. Okay, so this one is base case. Okay, alright, so next we get the data lah, copy the data that we have from the cases that we run just now lah, which is for the case A here, case A, meshing number A. Okay, so I just copy, show export to Excel, export to Excel. This is the results, so just copy lah, Control C, and then we put it over here, Control V. So and then just slightly change lah. So this one is case A. This is how many mesh number, which is 2400. 2000 or just 2400, or you can just type number of elements equals to 2400. For the base case, this one is number of elements is 300 times 200 is 60,000. Okay. Yeah, just leave this one should be velocity, so this one should be velocity, so we need to transfer it lah to the right side of the data. Then we can click and drag to make sure that need lah kita punya data tu sesuai dengan kemas lah. Okay, now kita nak run untuk case B, C dengan D. Same method as before. You can either clone ataupun you just modify and run. For example, case B kita nak run 150 and 100. Sorry, another one ya. Dia nak average surface friction coefficient. So kita nak data sinilah, buka lagi satu sheet over here. Average surface friction coefficient. Okay, so let's say this is case base case A, B, C, D lah. So you can copy lah. I copy the data just now sini. Okay, Control C. Okay, so you can, when you copy, maybe you can copy the source formatting or just the destination formatting. So in this case I prefer this one, so just let it be lah. Okay, now we put another column here, which is the average surface friction coefficient. Okay, so this is the data that we get from the simulation. So just now Tak apa, this one we can close already. Close. So get back to your simulation over here. Kita just okay. We want to get the coefficient, so which is the goal plot lah. Double click, and then you can just pick average coefficient, and then you can just show it. So the value is 0.003. So this one, you can either copy. So maybe, well, let's see what happened. So this one is for case A. So 0.03. I think we should change the resolution. Okay, let's just show. Sorry, let's show already. Export to Excel. Because export to Excel will give us a better resolution or better results. There you go. Different values. So just Ctrl C, and then we go back to the table that we have just now for case A, and then Ctrl V. At the moment, just leave it be lah. Quite a huge number of decimal points, so it's okay. Alright, we want to see the base case results, so you can go back to your simulation just now. So just okay, and then we can just double click over here lah. Double click, and then you can go back to your Go plots. Here just select average friction coefficient, and then we can our results are currently not loaded. Okay, close it. You need to go back to this load. So loading results. Okay, and then we go to the Go plot, select average friction coefficient. Okay, export to Excel to get a better accuracy lah of the results. So it should be here. Here, this one. Control C, and oops. This is the base case lah. Control V. Okay, so for case B over here, so case B should be where the meshing is 150 and 100 times 100, the total is 15,000. Case B, case C, and case D. So this one you can either clone and set and label it as case B, C, D, or you can just modify the results in the mesh here. Okay, global mesh 150 and 100, 150 and 100 and 100, and click OK and generate mesh. So tadi kita dah ubah mesh tadi. Where is it? Okay, global mesh ni kita dah ubah dia kepada 150 to 100. So okay, cumanya kita kena klik semula meshing, create mesh. So mesh, okay, run. Okay, run. And then okay, kita biarkan dulu, and then we click run soft run. Okay, mesh dah generate. So kat sini kita boleh baca meshing number lah. So 15,000 kat sini. Fluid cells. Okay, number of cells 15,000. Mesh generated already. So finish normally. So okay, dia not running. So this is the calculation. Dan kita tengok lah. So it takes some time. So our simulation has completed, so we can check the results. Even you can get the result over here lah. You see, this is the average friction coefficient. Okay, so alright, so just close it, and then just read your data, the XY plot. So this should be new lah, yeah. So export to Excel. Okay, let me close this one first. Okay, so this is the correct data that we should have. So I Control C, Control V, and sorry. Okay. All right. For the average friction coefficient, same thing. Just double click the go plot number 1 and then show export to Excel. And this is the average friction coefficient lah. Control C, and then here we go back to this case B lah. So it's slightly different. Okay, so you can do the same for case C and case D.